Welcome, everybody. My name is Jeff Kinsberg. I am the founder and visionary behind JAKTOOL. We are a precision product development and contract manufacturer focused on enabling our customers to bring forward technologies for healthcare and our nation's defense. JAKTALK is a podcast where we focus on the people and processes on how ideas are turned into reality. And joining me today, as you could hear from the intro, is a friend of mine and mentor, Ken Johnson, who is an aerospace pioneer. Ken, welcome. Thank you for joining us.
Glad to be here. Thank you.
So I said aerospace pioneer. Not many people are accredited with that. Honestly, this room isn't big enough to hold all of your accomplishments and experience. So humbly, thank you for joining us.
My pleasure.
So can you talk a little bit about, so you went into school as an engineer and came out as an aerospace pioneer, in your career. The unfamiliar became familiar. And I think, what our audience is interested in is how do the things get done that haven't been done before? And by the term pioneer, you created a roadmap and a path with a vision, with the support of a lot of people in industry. But could you talk to us about how you began and your career journey?
Yeah, I'd like to start that with a description of my 4 years at Rutgers, undergraduate, and this will be a pretty quick summary because it's not very interesting. I started off very interested in automotive mechanics and tuning automotive engines. Back then, we had V8s in our cars and that sort of thing. So I played with that a lot. That led to, by the time I was a senior, I had to do a capstone project, and mine was going to be removing or reducing air pollution from an automobile, this case, a Oldsmobile V8 in the laboratory. So I figured out ways to reduce or to make the air-fuel ratio better for eliminating unburned hydrocarbons, and I figured out a way to continue the combustion process to burn the rest of the unburned ones as it came through the exhaust manifold. And while I was doing that, and by the way, I love that. I had a wonderful time doing that.
I've never heard this story. This is great.
And so while I was doing that, I got an internship, which turned into a co-op at Lockheed Electronics, which was in Edison, New Jersey at the time. And my job there was as essentially a senior technician or a very junior engineer to help with some of the mechanics of spacecraft tape recorders. These are recorders that are used in satellites or in ballistic flights. And I thought, this is so cool. And as I was working with them, they were telling me how wonderful the tape recorder group is at RCA. And I'm beginning to lose interest in making the Oldsmobile engine cleaner and wanting to work in this really cool technology that these guys introduced me to. And I wanted to work at RCA, obviously. So when I finished my degree requirements, that's what I did. I interviewed with RCA, got the job, got assigned to the Aerospace satellite manufacturing facility here in New Jersey, and the rest is history.
Now, is that RCA facility over in Princeton, which is like the Sarnoff facility now?
Well, that's a really good question because the Lab B in that building is where it all began. Somebody over there figured out they could make a Videocon camera tube in miniature form. We put that into a box and flew it on a ballistic flight, and lo and behold, we could take pictures of the Earth. Oh my gosh, let's build a weather satellite with some cameras and other sensors on it. So that was the beginning of RCA in space. That was 1958 in Lab B, and 1960 when we launched the satellite.
Okay.
Yeah, on April 1st.
So that, no kidding.
April 1st.
So that kicked off your journey. So can you take us through that journey?
So that was 1960. I graduated Rutgers in 1966, so they got a head start on me. Okay. But I was tracking what was going on in space. Now, you may remember that the then Soviet Union, now Russia, are parts. Let's just say this is the same Russia. Was also interested in exploring space, and so they launched a satellite, Sputnik 1, and it made a eerie, useless noise, and that noise essentially scared the hell out of us here in the United States and a lot of the rest of the world, because they could put something in space and it worked.
Right, there was something overhead and
it was flying over. It covered its orbit mechanics, allowed it to cover all of the occupied territory of the globe, so everybody heard it. Then they put the second one, had a dog on board, so they were the first people to launch a satellite that did anything, and they were the first to launch a living being. And they telemetered the status of the dog and so on and so forth. It's hard not to get excited or scared out of your mind when you hear this stuff. Meanwhile, we're trying to launch vehicles, essentially launch vehicles, or things that we pulled out of missile silos and called them launch vehicles, and they were blowing up. And so we had a press of, we're not doing well, and they're succeeding, and we thought, Mr. President Eisenhower at the time, we have to do better than this. So that started the space race, and that string of events got me very interested in working in aerospace, and RCA provided the opportunity. So that's how I did it.
So in the 60s, you already had the vision that internal combustion was going to taper out and to be ahead of the curve in the space race.
You're giving me way too much credit. If I had that vision, I'd be where Elon Musk is today.
Different investing posture as well.
Yes.
So kicking that off, can you take our viewers through the journey of the different roles? And I know, I'm pretty sure your position remained in the same spot, but the name on the building changed, and how that, I guess, consolidation occurred through the industry.
Yeah, I love to do that because there's a few lessons in my version of that kind of a trail. Number one, the mergers and acquisitions. So I did work in the same building for 35 years, and but the name on the front of the building changed. And the mean time between changes was diminishing as time went by. So it was RCA, then GE, then Martin Marietta, and Lockheed Martin at the end. So that's how I lived through the process of changing different kinds of management styles. Very paternal at RCA, very directive at GE, and at Lockheed Martin. Very people focused, but very performance focused at the same time. Mm-hmm. So they had a nice mix of that. So I started there as a junior engineer, and then an associate engineer, and then engineer, and then senior engineer, and finally division fellow. But at some point in time, I was the head of a mechanical design group and designing weather satellites. And we made, and then communication satellites. But we made a lot more than just those. And so I was offered the job of being in charge of all of the design groups. And I said no, because I want to develop systems engineering skills. Because ultimately that broadening will help me be what I think I want to be, by the time I get into senior management. So, the reaction of most of my friends, coworkers, people who had similar jobs to mine was, I can't believe you did that, because that's your trajectory and you just left the trajectory. Yeah, but that's not the trajectory that I want. So, let's talk about that. Now, it's the best decision I ever made, because that broadening experience, now in charge of other kinds of people, not just mechanical and aerospace engineers, helped me to become, next was a senior manager or division manager of all of the physical engineering, so propulsion, thermal, and just name it, and it was included. And then ultimately, I became general manager of engineering. Mm-hmm. That position had 2,500 technical engineering folks, and then a couple of hundred technicians, really, really strong, powerful technicians. Another story, but I won't go there right now. And so that from that job, I became the vice president general manager of the company. So
I want to just point out that I feel that the word satellite, right? It's ubiquitous. It's this this technology that's taken for granted, right? So now we go back to the mid '60s, right? There's no GPS, there's no satellite radio, there's no high speed internet over the satellite, there's no weather satellites. The technology isn't there, right? So all of these things that are just worked into our daily life, like the map on our cell phone working, right? This is all powered by that, and I don't want to say it's taken for granted, but it's matured so much that it's a part of us, right? How do we function? I don't know how to, there's, when you go on vacation, nobody's planning a trip. You're punching the address into Google and you follow the phone, right? So it's affected our behavior. But I guess but on that same thought, so you made I guess, correct me, it sounds like a conscious decision to as you move towards a system level, dealing with more integrated pieces, you're also dealing with more people and personas. So is it fair to say that there's equal weighting or even more weighting towards personnel management and guiding and coaching those folks, as opposed to just strictly being in the technical? Or like, did the challenge of people excite you at all, or was it more of a challenge of multiple systems? Or
well, as I grew in that field, I became far more interested in getting groups of people to work well together than I did working the technology myself. Because I, as I say frequently, the young college graduates know a heck of a lot more than I do. So my job is to make their job easy to understand and easy to do. And I have always been interested in project teams rather than teams associated with the technology of specific skills. And so I didn't write this book, but I did study a book called, I forgot the name of the book, but it doesn't matter. It's a study in how to organize such that you have expertise in the skills that's being developed constantly, and a group of those highly skilled people working then together on a specific program where you need all that stuff. So you need a really good pitcher, a fantastic catcher, a great first baseman, great outfielders to have a successful team, and that's how you win. Everybody's really good at their job.
And if you're missing any one of those roles, you're not going to win.
It's very difficult to overcome. I don't have anybody who knows how to play third base. It's a great example. I think it's a really good way to discuss matrix organizations that need skill sets and also need program expertise. So I didn't introduce that at RCA, but I really did manipulate it to make it work the way I thought it should work.
Yeah, that's we as an organization here, right, granted, a fraction of the size of the organization you were involved with, we're struggling with those same things of what are the areas of concentration of knowledge that the team members need to be successful. Looking at risks of having redundancy, and also not only being responsible for this information now, but what does the next set of information look like that they're going to grow into, and what does that knowledge or training path look like? And a lot of the time, I'd say there's a fair amount of curriculum and mentorship out there, but some of it is just feeling your way through the dark of talking to people and looking at the signals and adjusting.
Yeah, and you just touched on an important aspect of working in a matrix organization. So the people on your team don't have your background. You're the expert in mechanisms. Somebody else is the expert in thermal management. Somebody else is a propulsion engineer. So they don't necessarily speak the same language, or at least the same way that you do. And so one important characteristic is good communications, the ability to express what is going on and why I need a little bit more resource here because the thermal system's not going to work. Where am I going to get that? So you have to be able to describe problems and potential solutions well to the rest of the team so we can work out what's the best system level look at this.
Yeah. So we've got our president and CEO, Christy, had this vision for this core values-based curriculum here, right? What was making us successful? What did we want in the talent that we attracted? What did we want as qualities in our customers? And great communication is one of the foundational pieces. And what I learned is that the best part of communicating is when you listen.
God gave us 2 ears and 1 mouth.
Right. And it's tough because you're in a room and everyone's trying to advocate their message and their position, but there's a lot that can get lost when everyone's trying to talk on top of each other. So I guess with the communication piece, was there any, stories or lessons learned or takeaways for, I guess, our audience?
Well, I think from the perspective of the group leader or the manager, section manager, or whatever title it is to make sure that communication difficulties don't impede progress and don't lead to a less than optimum solution at the system level. Remember, I told you at the early part of this that I wanted to move out of strict mechanical design and into a more mechanical systems look. And that was why. I wanted to figure out ways to make sure people are communicating exactly what they want to say and not something different. Because, we all have lenses that we see through, and we also have microphones that we speak through, and those aren't perfect. And so you have to work around that. That's a really fun thing to do. Mm-hmm. If you get the chance to do that, that's a fun part of leadership.
Since I got a bad joke, so since satellites touch on telecommunications, you could say you're on the same wavelength.
I suppose.
My daughters would tell me that's a bad dad joke.
She has a point.
I'm a bad dad. So can you describe, what are the main purposes for satellites? I guess in a nutshell, how they're used, how they're launched, and kind of break them down into bigger, broad categories for our listeners?
Sure. There's a lot of different reasons to want a satellite. By the way, let's be specific about our language here. Satellite is a spacecraft that's orbiting something. Spacecraft is a thing that's in space and going someplace. So I'll give you the example that raised that in my conscience just now. JPL launched a mission called, I forgot the name of the mission, but I have it written down in my notes here. And its job was to fly out to Jupiter and even Pluto, and even get to the edge of the atmosphere, not the atmosphere, obviously, the galaxy, and go where no man has gone before. Mm-hmm. And so that satellite doesn't look anything like a weather satellite or a communication satellite. Weather satellites have a bunch of instruments that are trying to see the Earth, measuring all kinds of different things, and a solar array providing power for that. And so it flies in a certain orbit where it can see the same scene over and over and over again. And after a period of time, you develop trends, you develop what's going on in that. And by extension, you've seen all the scenes all the way around the globe. You can do global climate. A communication satellite sits in one place over the Earth, moves at an angular rate in its orbit that matches the Earth's rotation rate. And so it looks like it's stationary from the ground. So you have a little antenna you put on your house. It aims at the satellite. The satellite never moves from that spot, as far as you know, and so you get great picture on your television. Or in your business, you may use satellite connectivity to do things like checking credit cards or whether or not this person has the capability of paying for this, that sort of thing. So those are communication satellites. Landmass satellites, things that are looking at what's the ocean doing, wave height, wave temperature, current, today's current versus yesterday's current, temperature of the air above the ocean, all the way up to the top of the atmosphere. We can, we do that. And land, there's a fire, there's an explosion, there's an erosion problem. We can manage that. We can manage crop health. And that is by selection of sensors. And then GPS. Mm-hmm. GPS was originally a way to steer of advanced weapon systems launched by a Nautilus submarine. And then it became a little bit more available to the rest of the universe than that. So it started being used for airplanes, ships. People used it for doing very, very complex land surveying. And ultimately, that $4 billion investment by the Air Force allowed you to have a $100 radio in your car that knows exactly where you are and what speed and what direction you're going.
Is the Air Force tracking us?
Probably.
So I guess you touched on the environment. I noticed over the weekend there was some news about scientists detecting current changes in the Atlantic Ocean, which would be very detrimental to our weather patterns. How do international agencies collaborate and monitor climate change and its effects?
Well, it turns out that a lot of countries have weather satellites. Some have the ones that sit over the equator and just stare at the same weather scenery, so to speak, all the time. So when a hurricane starts to move across the Atlantic, we can track it because we're always staring at the Atlantic. Mm-hmm. But there are others, and several countries have those. We have those. India has those. China has those. Russia has
do we
those.
Get along? Do the networks talk together?
Yeah. One great example of that is we have search and rescue missions on our weather satellites for the United States. So a small radio on your airplane or in your sailboat will communicate with that satellite if you get in trouble and tell it where you are, and it'll create a signal that will cause people to come and get you. But that same thing flies on a Russian satellite. And probably on the French satellite. I don't recall exactly, but I'm pretty sure it does. And so all those are shared. All those data are shared. And that's what you would hope. Mm-hmm.
So that sharing of data allows humanity to collaborate and plan ahead for natural disasters.
Yeah, and rescue people that got caught in something that happened, and maybe it was whatever it was, some sort of a disruption in the normal course of things. Maybe you ran out of fuel. Maybe it's just that. Mm-hmm. But that is a great example of cooperation across countries and across ideologies as well. We do the same thing with GPS. There are 2 or 3 major GPS systems in space, and they're all very similar, and we share access to that data with many other governments.
So I've gotten my notes that during your time at Rutgers and later work with the Polar mission, there was a lot of work with climate. Can you talk about the Polar mission and what its objective was?
I have a little bit, but let me just talk a little bit more. Polar satellites, they fly over the poles but not at 90 degrees, at a slight angle, so that their orbit precesses around the Earth at the same rate that the Earth rotates on its own axis. And so if it crosses the equator at noon, it'll always cross the equator at noon. So
You're always getting the same timestamp of that geographical piece.
no, the equator, the latitude.
Okay.
But the Earth is rotating. So what's at that latitude when it crosses next orbit isn't what was there last orbit. So imagine now it's doing that 13 times a day, and over a period of 2 or 3 days, it's covered the entire globe.
Okay.
And we can fly one at noon, we can fly one at dusk, let's say, where the shadows are very long. And so comparing those two data coming out of a similar spacecraft but flying in a slightly different orbit, we can learn a lot about the ecology of the Earth. We learn a lot about weather systems, but we're monitoring so much more than weather systems. Mm-hmm. We're monitoring the effect of the solar wind on the Earth's atmosphere. We're monitoring the content of the atmosphere. We're looking for ozone in the atmosphere. And all this is done by these Earth-observing polar missions.
Okay. I guess we'll get to it in a later section of our discussion, but I'd like to get your thoughts later about whether they're monitoring extraterrestrials.
I don't think so. I've never heard of that.
So you made a comment about we fly, right?
Yeah.
I don't have an appreciation, and I assume most of our audience doesn't, right? When you say we fly a satellite, what is the process to get this, orbiting device where you want it?
Yeah, it's there's many, and it's always a trade-off. There's always decisions to be made. There's like, which one of these options am I going to use? So let me say a couple of examples. You can buy a launch vehicle that you bolt your satellite to the top of, and it will fly to the altitude that you want to be, and it will circularize the orbit for you. And so when it lets you go, you're in orbit. By the way, I use words like fly, bird for the satellite itself. And those probably are the ones that will confuse people the most. But I use those to talk about what orbit are you flying in, what's your direction and speed, and we call them birds. I don't know why that came to us. I guess through our Air Force connections, they call their airplanes birds.
It was their investment. They named it.
They call it what they want.
Right.
Yeah. So that's one. The launch vehicle just puts you where you want to be. Another one is you bolt yourself into a shuttle. Now, this is not going on anymore, but for a while, you could go into a shuttle bay. We would launch the shuttle, and it would go someplace, open the doors, and you would be released into the, was not atmosphere, but into that part of space at that moment that was right for you, for the orbit that you wanted to end up in. So I'm struggling to not get too technical with this stuff, because there's a lot of very intricate jargon that goes with orbit mechanics. Another one is the launch vehicle, which we can also call a booster, takes you somewhere and drops you off, but that's not where you want to be. So you brought your own staging engine, a big solid rocket, that you can ignite at the right time so that you end up in the orbit that you want.
I understand this is challenging. I've got a rocket scientist talking about rockets, and I'm trying to simplify it into a few words that I can understand. So what are some of the biggest impacts that you think that this technology has brought to us?
I think saving lives, because we know where the big storms are, where they're going, roughly what time they'll get there, is huge. Can't diminish that. We know to evacuate areas because we know there's something big happening. My wife was going to fly home from a tour that she did of a city in Italy, and the skies were closed down to the west because of a volcano eruption that filled the sky with particulates and made flying in an airplane risky. Mm-hmm. You could still fly west, to the east, but the shortest trip would have been to the west. So she was prepared to stay a few nights, By the way, she was in Venice, so staying a few nights,
No problem.
didn't have to really wrench her arm around too far to convince her that was the right answer. So that was something that we knew happened, and we knew which way the wind was blowing the debris that came out of this eruption, and how broadly that would influence air flights, temperatures on the ground, storms, and that sort of thing. Another example of that is we can monitor the dust that comes out of sub-Saharan Africa and gets blown across the Atlantic Ocean. Where does it go? How widely dispersed is it? You can see it all clear as a bell from these satellites that are doing landmass or weather monitoring.
I don't have an appreciation for how you go down this career path. So for the younger spectrum of the audience, how do you say, I want to utilize this data and educate myself and go down this career path? Do you have any suggestions?
Well, I do. I think young graduating engineers, in fact, I think any young graduating folks should want to find the job that makes them happy. And because I think that happiness is I was going to say a commodity or a payment, and it sort of is, because if you're really happy in what you do, you think you're making a contribution, it makes you proud of yourself. It's self-actualization. You kind of feel good. Mm-hmm. If you're in a job that doesn't do all those things, you might feel okay, especially if you have a good paycheck. But if you're in a job that has none of those things, you're going to be unhappy, and you'll always be unhappy until you change jobs. So when I tell that to students at Rutgers, they'll say things like, well, I don't know what my passion is. I don't know where I'm going to be that happy. Maybe I'll join the space business like you did. And I usually say, that's not necessarily the right answer for you. You have to find that, and don't be afraid to try to find it and fail. Mm-hmm. Don't wait for your first job until you've found nirvana.
Right.
The first job is really important. It teaches you a lot of things. And so these are things that happened to me. So, do you want to do this? Well, I want to do something similar, but not that. Yeah. And you won't be able to express what it is that you want right away, but that will come with time. And if you allow yourself to change jobs, and by the way, nowadays there's no stigma with changing jobs. Mm-hmm. Even pensions and other benefit packages are portable these days in most industries. So there isn't anything that would hold you back.
Right.
So I give strong encouragement to that. And don't, we're talking about my career right now, but that might not be a match for anybody who's listening. Mm-hmm. Maybe the fact that I was willing to change or turn down the job that everybody thought I should have would be motivational. But I'm not sure that entering the space program as a junior engineer is the very best thing that every single person listening could do.
Right. So the audience doesn't necessarily know this, but you and I started working together. You kind of pulled me into the Rutgers giving back fold about a dozen years ago, and we've done a lot of projects together, working with students, design judging and mentoring and coaching, and that's when we were at the last event, I think in November. I get such a kick, and I see you do too, out of working with and coaching the students. And, what's interesting is, I founded JAKTOOL not around a specific technology or industry or purpose. I founded it because I enjoyed working with my peers. Right. And I wanted to work with them. So for those who don't know, I was in charge of the racing team when I was there in the late 90s for a few years. And people said, oh, you must love race cars. I said, I don't really love them or hate them. I just want to work with a dedicated group of people that are passionate about something. So I think when you're talking to students or people are in their career to kind of what's their purpose and what's shaping their direction. You made a comment earlier about the management styles of the organizations that you worked at,
Mm-hmm.
right? Some are softer emotionally, some are more direct, and I don't know. It takes time to figure that out, what you want. When we were at the last that event in November, I said to a student, I said, do you want to work on the best thing ever? You get two options. You can work on the best technology ever, and your team is terrible, or do you want to work on something average and have a great team? And he says to me, I want to work on the best thing ever, and I'll sacrifice the personalities I'm working with. And I said, I don't relate to that because that's not me, but I totally understand it. We're all a little different. So do you, and it's tough because that critical thinking of, as a student, you're looking at the technology, what's, where are the jobs at, but also it's like you were saying, like, what can you do? I'm going to use this word, and I guess it might be on the edge with some engineering, right? Because it might not fit with all engineers, but there's almost like this whole, like, what keeps you whole or almost like spiritually intact to follow a specific, career path, right? To get that rewarding piece out of it. It takes time. And it sounds like you figured that out pretty early in your career.
The word I liked for the one you were just using is self-fulfillment or self-actualization.
Mm-hmm.
If you feel fulfilled in doing something, you're going to be very, very happy doing it, unless you're in the poorhouse. But for engineers, most of us are well enough paid that we can buy a house, we can buy we can live in the house, we can buy food, we can, have some, entertainment or hobbies. So none of those things are going to motivate us. None of those things are going to make us feel fulfilled. But if we make a difference in our careers that impacts mankind or humankind or changes the spectrum of things that we can do for each other, somewhere in the language, there's a phrase that will appeal to every single person listening to this, that, that's me. Mm-hmm. Self-actualization, that's me. But it's not space. I'd rather be working in agricultural engineering mm-hmm. rather than space engineering. And so that's cool. Whatever that is, once you find that, you're good.
Right. That purpose gives you drive.
Yeah.
So we've got the common bond over Rutgers. You're wearing the Rutgers pin, and mm-hmm. So what's your involvement in Rutgers, and why has it been so important to you?
Well, I believe, I guess there's a lot of ways to answer that question. One is that I believe that Rutgers gave me a great start. And so the education I got at Rutgers was better than the education that many of my peers got. That's better than many of my peers earned when they were at school at some other school. Mm-hmm. I tell lots of stories about that. I won't do that here, but I actually do believe that it's one of the very best engineering schools. So that kind of makes me want to be part of the Rutgers community. Now, a word here. Early in my life after graduation, and early in my life with my wife, I was kind of busy doing other things, buying a house, raising kids, and didn't have a lot of excess money to give back. And so there's a starting period where people don't really expect that kind of connection, but neither do they want you to ignore them. I mean, you want to be part of this. University is spectacular in many ways, and its community is spectacular. So you don't want to not be part of that. You might not be the biggest donor. That doesn't matter. What right. matters is that you don't walk away.
Right.
But I've gone maybe over the top. So I'm vice chair of a board of trustees. I sit on the board of directors of the foundation. As you know, I'm very active with the School of Engineering, and I get but I'm retired, so I'm not working for Lockheed Martin anymore. And so therefore, I get a lot of pleasure, satisfaction, self-fulfillment out of those volunteer tasks.
Mm-hmm. Yeah, I agree with you. That for our viewers who are not retired, it's a difficult balance to find that philanthropic. How much time you put in, right, and have a family, have a career. I've been through this exercise where you say to yourself, I was with other small, medium business owners in a group, and we went through this exercise of, you're going to die tomorrow. Oh no, bad news. Okay. Now that you're not going to die tomorrow, or you're going to die tomorrow, but what are all the things that you didn't accomplish in life, right? And make that list, right? And almost at the top of everybody's list is mentoring and philanthropy and giving back, and vacations and all the good stuff. But the question became with the group, well, if that's the top of your list, how come you're not doing it now? And it makes you really think and come up with a plan, because we're all still here. The time is now. You can make a difference. So I know that you provided a financial pathway for Rutgers Best and Brightest. Can you touch on that?
I think that I have become very aware of the number of students who are very bright, but don't have the financial resources to go it alone, or they have run up against some unplanned needs, and that those needs would interfere with their concluding their education on time. And so if they decide, I'll just not buy this book, it's too expensive, and I'll take that class next year, but I was not planning on being here next year, the cost of another semester or two far outweighs the cost of the book. So I'm very enthusiastic about these help programs that can help people that have just suddenly run into a barrier, and it's unmet financial needs. And the other side of that is I like to help people who I think would be outstanding scholars, and do really great things with their careers once they graduate. And so some of this is for scholastic excellence, and some of it is just plain financial need. And how do you balance those? Well, there's no equation. It's a case by case kind of thing.
You're investing in our collective future.
Yeah. But
that's special.
It's I don't know the details, but I know the students who get this help. They're fantastic, and I know they're going to do well in their careers.
Yeah. So I guess before we wrap up, I've got a little game I'd like to play. But is there anything that you'd like to share with the audience, or can we move on to the segment where I torture you with the game?
We could do the game.
Yeah. Okay. So the game is called I Plead the Fifth. You can either say I plead the fifth, you can say that that's classified, or you can answer the question if you'd like. I'm sure my mind runs wild with probably the things that you've been exposed to over the years that, we all want to know what's real and what's not. So let me ask you, how close did we actually get to war with Russia during the Cold War, or the Soviet Union?
I don't know the details of if we ever got to a high DEFCON. I wouldn't know that, but just reading the press, I know that we had missiles 90 miles away from Florida, and we had a very brave president stood in the way of that happening and made sure they left. But we have had skirmishes, and some of those have to do with us wanting to take pictures of things that they're doing, and so that tends to raise the ire of the other side, as you can probably predict. That's happened a few times. Whether it got us close to a real war, I don't think so. I think saner heads prevailed in all the cases that I'm aware of.
Did you have a red telephone in your house that was connected directly to the VIPs?
No. I don't know, but everybody had my phone number.
So, all right. How can you hide a satellite?
You can, but not forever. You can disguise the fact that you launched one by launching it alongside another one.
Okay.
That, let's say one is as big as this building, and the second one is about the size of this room. So if we launch that together, it would take a long time for the small one to be separated enough that you'd be able to pick it out. Now, there are systems on the ground. Everybody has these, trying to catalog and track everything that's up there. And so that's a difficult process, and you can't hide it forever, but you can, you can do that. The biggest things that are up there that I know of are parts of boosters, like an upper stage that doesn't re-enter on its own and doesn't have any propellant left, so you can't tell it to re-enter. And they fly around for quite a while before they come back. And I guess you could hide something near one of those.
So I had a question that says, is space trash a threat?
Yeah,
space trash
sure
a threat.
is.
So
Absolutely.
So it's a threat, but it could also be a cloak.
There's a lot of junk in space that came from used, parts of boosters. We're finished with that. But what are you going to do about it? Well, nothing. It's just going to be there. There were times when we were using technology that would, in the process of releasing the spacecraft in its orbit or deploying its solar panels, et cetera, would release some debris into space. And that's all stopped, but it's still there. And so there are people that track every single piece that's like the size of maybe a square meter or larger. They're all tracked. And it's probably less than that, and I don't know the answer to that one.
Satellites that are, on the search for extraterrestrial intelligence, SETI, have we found aliens?
I don't think, you mean that things that we captured and brought to Area 51
Yes.
so we could study?
Yeah.
No, I don't think so. I've heard many stories about that, but I have a feeling Hollywood was involved in most of them. So I don't think so. Let me say it this way more definitively. None that I worked on.
Okay. That's a definitive answer. All right. How susceptible are satellites to being hacked?
The earlier ones vary. All you needed to know was the frequency of the command receiver and how it was, how the command that you wanted to send, how would that be modulated into the waveform of the signal? That's a real simplification. But we can make that privileged information. We can make that classified, and so that you can't know that. Or we can make the signal, the content of the command package classified, and we can make it difficult to hack. But, the tools on how to hack things keep increasing. And so we have to keep on our vigil for that. There are many of our satellites, though, that do military functions, and there's no way to get into those. They have very specific coding that they use, and they're encrypted. Their commands are encrypted, and so are their messages that come back are encrypted. So I think we're pretty safe in that regard. As other nations have shown, it's a lot easier to destroy them than it is to take them over.
So I guess to conclude, we've both been in contact with the Rutgers Rocket Propulsion Lab.
Yeah.
They're a group of about 80 students that annually design, build, and launch a rocket to close here, about 11,000 feet. I had this discussion with them a few weeks ago about there was a term for it, but what does the radius of, landing look like? How big of a farmer's field do they need to do this? So that was pretty cool. And I would love to when I was talking with them and, some of them saw you speak to their senior design class, and I think that there's just to have in that community, you as a resource, this
Sure.
pioneer to provide that insight and guidance. Would you be open to supporting another discussion where maybe we bring in 2 current students and they can you can help demystify the engineering aerospace universe for them?
I would certainly, and it could be a larger group than that if that would be their preference. And I'm going to have a lot of questions for them, so it'll go both ways.
Awesome.
Yeah, I'll be happy to do that.
Awesome. Well, Ken, I really appreciate your time and for joining us today. This has been a really wonderful talk, and I hope that everyone out there enjoys it as well, and get some perspective on the right steps to take to advance their career or to find that purpose that drives them. You're an inspiration to all. Thank you.
Thank you much. Yeah, it's been my pleasure.
Thank you. So thank you everyone for tuning in for this episode of JAKTALK. Please find the button below that, on this window, and like and subscribe, and stay tuned for the next episode when it hits. Thank you very much.